Hi, my name's Ross. I'm going to run you through a quick tutorial to calculate a universal beam depth based on deflection and check its capacity. We're going to start from a pre-written JOT which is available in the premium area. If you go under Australian Standards 4100, and then you can choose a UB from a moment deflection or choose a UC for moment deflection. We're going to choose UB, and once clicked it, it will insert a safe copy into your current empty sheet, which is this calculation. The way this works is we have UDL dead load, UDL live load is predefined, which creates your factored and unfactored UDLs. There's a simply supported beam calculation that calculates the moment from the span, the width, and the UDL ULS. And then there is a UDL deflection with the deflection limit set to currently 10. You can change that to be span on 250 or span on 360 or whatever use case that you would like. And then it back calculates the I required from the deflection calculation of a simply supported beam. You can obviously change the equations here to a different beam equation if you want to do fixed pin, or if you want to do a cantilever. You can either drag in from the example calculations from the JOTs, or you can write your own, just typing it in. Then based on that IX, it runs a search on section. Section is the data table that you see here on the right hand side, and you see IX in this column going down. So it's going to be looking for 320 million. The actual search here is done for 320, so it matches the data in the data table, and it's going to search for return the upper value on IX, but it is also searching IX. So it's going to go to IX, it's going to come down here, and it will find 320, so it's the value between these two. So you can see 296 and 335, and it's going to return the upper value. So the upper value is this one here. So it's going to be a 460 UB 746, and it gets all of the associated properties for all of those, and you can see here the name has found 460 UB 74. It then does a quick back calculation of what the actual deflection is based on the I for this 460 UB, and you can see it's slightly lower than the limit of 10, which is 9.5, and it moves on and it does a simple 4100 check for the design of a laterally restrained beam. So it calculates the thigh MSX and then checks that value again, the Mmax, using this result, and you can see that it passes, and then it calculates what the lateral spacing of the restraint should be to be correctly identified as a laterally restrained beam. And then you can see the name of the beam and the result. Now what we can do, if it makes it slightly easier, is up here we could put in a result underscore num, and that will give us the answer to the chosen beam. Result is an interesting function. It takes the very last definition of the variable that it's put in there, in this case nam. Normally MathJot works on a height ordered calculation, so the variable is defined below it until the next time it is redefined. So you can see here L is defined as 8. If I was going to put up here L is equal to 2, from this place until here L is 2. But the moment I take L past this and release, you can see the recalculation has worked, and the result is now showing 150 UB14. So basically you can see it's L is 2 until here, and then from then on L is 8. We could also assign this to be an array, so 2 and 8. And if I took that through and passed and dropped that in, I would now get 2 numbers because it's run the calculation twice based on that. And it's a fast way of calculating multiple beams. You'd obviously have to put make sure that the UDLs are also compatible, so you might have to make those arrays of the same size, so that would work too. Okay, thank you very much.